The universe wasn't always filled with stars and galaxies. Imagine a vast emptiness, a cosmic void stretching endlessly in all directions. This void was not completely empty, though. It contained thin wisps of gas, mostly hydrogen and helium, the simplest elements in the universe. These elements were remnants of the Big Bang, the event that created the universe. The cosmic void was a quiet place, waiting for the drama of starbirth to begin. Over eons, gravity drew these scattered atoms of hydrogen and helium together. They clumped together, forming a massive cloud of gas and dust known as a nebula. Within these nebulae, the seeds of stars were sown. These primordial clouds were not uniform. They contained regions of varying density, with some areas denser than others. These density differences would prove crucial in the star formation process. As the nebula grew larger, its own gravity became stronger. The denser regions within the nebula attracted more and more gas and dust. This process, known as gravitational collapse, caused the nebula to shrink and spin faster. As the nebula collapsed, the temperature at its center increased dramatically. The once cold and diffuse cloud began to heat up, setting the stage for the birth of a star. Section 4. A star is born. The protostar ignites. In the vast expanse of space, amidst swirling clouds of gas and dust, a remarkable transformation begins. The collapsing nebula formed a hot, dense core called a protostar. This core, under the relentless force of gravity, started to contract and heat up. The protostar continued to gather material from the surrounding cloud, growing larger and hotter. As it accumulated more mass, its gravitational pull strengthened, drawing in even more cosmic material. The temperature and pressure at the protostar's core eventually reached a critical point. This intense environment set the stage for a dramatic change. At this point, a new process began: nuclear fusion. The core's extreme conditions allowed hydrogen nuclei to collide and fuse. Hydrogen atoms, under immense pressure, fused together to form helium, releasing an incredible amount of energy. This energy radiated outward, illuminating the surrounding space. The protostar had ignited, becoming a true star. This ignition marked the birth of a new celestial body, shining brightly in the cosmos. Section 5. Nuclear fusion, the heart of the sun. This is where the magic happens, deep within the core of our star. Nuclear fusion is the engine that powers stars. It's an incredible process where hydrogen atoms collide and fuse together to form helium, releasing vast amounts of energy in the process. In the core of our newly formed star, hydrogen continued to fuse into helium, releasing a constant stream of energy. This fusion process is what makes the sun shine so brightly and provides the heat and light that reach us here on Earth. This energy radiated outward, providing the pressure needed to prevent the star from collapsing under its own gravity. Without this outward pressure, the immense gravitational forces would cause the star to implode. The star entered a long, stable period fueled by the nuclear reactions in its core. This phase, known as the main sequence, is where the star spends the majority of its life, burning hydrogen into helium. This is the stage our sun is in today. It has been shining for about 4.6 billion years and will continue to do so for several billion more, providing the energy necessary for life on Earth. Section 6. The solar system emerges, a cosmic dance. The story of our solar system is one of intricate beauty and cosmic choreography. As the protostar collapsed, it didn't use up all the material in the surrounding nebula. This leftover material played a crucial role in the next stage of our solar system's formation. The remaining gas and dust formed a swirling disk around the newborn star. This disk, known as a protoplanetary disk, was the birthplace of future planets. Within this disk, particles collided and clumped together, gradually forming larger and larger objects. These collisions were not random. They followed the laws of physics, leading to the creation of planetesimals. Over millions of years, these clumps grew into planets, moons, asteroids, and comets. Each of these celestial bodies has its own unique story and characteristics, contributing to the diversity of our solar system. Our solar system, with its diverse array of celestial bodies, was born from the remnants of the sun's formation. This cosmic dance continues to this day, with each planet and moon following its own path around the sun, creating a harmonious and dynamic system.